All right, guys, lesson 21. A. How do we find the inverse of a given function? Keyword being inverse for today's lesson. Okay, so remember, just think about what inverse means to you, right? Inverse kind of means to like undo something. That's really what we're going to do today. We're going to undo some functions. So start out with this do now. If you need some time to go ahead, to work on this do now, please go ahead and pause the video. There is a hint up here for you. Please, I don't write those for myself. I write those to help you guys out. Otherwise, let's get started. Color of the day, let's do purple. Write each relation as ordered pairs and determine whether or not it is a function. So remember, ordered pairs are just coordinate pairs. So for relation f, I have 1, 6, it's too big, 2, 7, and 3, 0. Here are my ordered pairs, and this is definitely a function. I know this is a function because none of my x values repeat. Right? They're all different. Okay, so let's do the same for relation G. Let's do that right here. So 4 gives you 8. 5 gives you 8. And 6 gives you 9. Again, this is a function because none of my x values repeat. Some of your classmates said this in class. So as long as we know that our x values are not repeating or our input values are not repeating, it is a function. So the inverse of a function, and we write this as f -1 x. Okay, so notice the little -1 is on top, almost like an exponent, and we can be this can be found by switching the first and second element, so by switching x and y. Represent the inverse of relation f as ordered pairs. So my first ordered pair was 1, 6, so if I switch that, then it's going to be 6, 1. My second one is going to be 7, 2. And my third one is going to be 0, 3. Kind of easy, right? All we're doing is switching our input and output values. And absolutely, this is a function, right? Because again, my x values are not repeating. So and I'm over here now. Since the inverse is a function, we call this 1-to-1. So remember that. If the inverse is also a function, then we call it 1-to-1. Represent the inverse of G as ordered pairs. So G, we have our first ordered pair was 4, 8. So I'm going to have 8, 4. And then we had 5, 8, which would mean my second order pair is 8, 5. And then I had 6, 9, which means my third order pair is a 9, 6. Is the inverse of relation G a function? Absolutely not, right? We have repeating x values. So 8 is repeating. So no. This is not a function. Because the input of 8 has 2 outputs. Okay. So since the inverse is not a function, we're going to call this a many-to-one. Let's try this problem together. You can go ahead and pause the video right now if you want to try it by yourself first, to really understand whether or not you understand the concept. I always like to rewrite it, and one of your classmates taught me this trick because reading it horizontally is a little bit difficult. So if I take a look, 3, 4, 5, 8. Okay, absolutely, this is a function. And now let's see if the inverse. So I'm going to put the inverse. And for the inverse, I have 6, 3, 3, 4, 2, 5, and 6, 8. And this is not going to be a function. My inverse is not a function because I have repeating inputs. So since the inverse, this one was good, right? And this one was not. Since the inverse is not a function, we're going to say this is many to one. Okay, so that's with coordinate pairs and mappings. Okay, so with mappings, what we do is we change it to coordinate pairs, and then we work from there to determine whether or not it is a function and whether or not the inverse is a function. So now we're going to focus on graphs. To tell if a graph is a function, we use dramatic pause. I was hoping you would fill that in for me. We use the vertical line test. Vertical line test, okay? Now to tell if the inverse is a function, we are going to use something called the horizontal line test. Ready for this? So first, let's take a look at this graph and let's just determine if it's a function. If I draw vertical lines, notice that I will always hit this graph at most at one point. So the original graph is a function. So I'm just going to write myself a note. Original is a function. And then let's go ahead and use the horizontal line test to see if the inverse is a function. Look at that. No matter how I draw my horizontal lines, I only hit my graph at most at one point. So my inverse is also a function. Since they are both functions, yes, this is one to one. Okay, next one. Let's use our vertical line test. Go ahead, you see how I'm drawing all these lines? And it only touches my graph at most at one point. That makes it a function. So my original is a function, and now we're going to use the horizontal line test. Oh snap, look at that. I touch my graph at 2 points using the horizontal line test, which means that my inverse is not a function. Since my inverse is not a function, no, this is not called a one-to-one. What do we call this? We call this many to one. And let's just do this really quickly. We're going to graph the inverse of f. So what I'm going to do is actually I'm going to find each of these points. So this first point I'm going to shade in brown. That's the point -5, 6. Well, the inverse of that is going to be 6, -5. Remember, we just switched the x and y values. So 6, -5. That's my first point. Okay. The next one I will do in this pinkish color. My next point is -3, 2. To find the inverse of that, we flip our coordinates. So this becomes 2, -3, 2, -3. And let's connect. I'm going to connect with one color. There you go. Okay, my next point, let's find that here, is the point 1, -1. And again, to find the inverse, let's flip our coordinates. That's -1, +1. So -1, +1. And then I'm going to connect. I like to connect them as I go so I do not get confused. And let's do this last point in purple. 6, -3. If that is my coordinate pair, the inverse is going to be -3, 6. If I go ahead and plot that, -3, 6. And then I connect. I just graphed the inverse of my function. Beautiful. Okay, let's do this last problem together as well. On the set of axes, let's graph the function h of x equals to 2x plus 3. Remember, we try to use y equals mx. I'm going to write that on top. mx plus b. So we begin at +3. Right, that's where we begin. And our slope is 2/1, which means let's go up 2 to the right 1. 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 And once you can't do that anymore, we're going to do the complete opposite. Let's go down 2 to the left 1. So we're really just continuing this pattern here, down 2, left 1, down 2, left 1, all the way until I get to the edge. And please make sure you are connecting this with a straight line. Okay, I know I said that. Let me try to fix this. No. Straight line, guys. Straight line, guys. You guys have an ID card at home. There you go. And I'm going to label this with h of x. That is h of x. So now I need to find the inverse. Okay, so I'm going to pick some points. This is the point 3, 9. So the inverse of that would be 9, 3. 9, 3. Let's pick another point. I got the point 2, 7. The inverse of that is going to be 7, 2. So 7, 2. Let's do another one. 1, 5. The inverse of 1, 5 is going to be 5, 1. We're flipping the coordinates again. You shouldn't be able to notice the pattern for yourself right now, but if you do not, we want to continue. Let's do 0, 3. The inverse of that is 3, 0. And if you really notice the pattern, right, let's try to take a look. My pattern is I'm going down 1, left. That didn't work. Down 1, left 2. Down 1, left 2. Down 1, left 2. So if I just continue this pattern, down 1, left 2, 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 I get my inverse graph. And we need to label this. Okay, this is the inverse. This is how we denote it. H, and then we have that little -1 on top to indicate that's the inverse of x. And that's it. Please make sure you guys are going online. And for those of us who don't have the sound on, I'm going to write it out right now. Do your delta math. That's all. Bye.